Unit 13, Lesson 2, and this is pretty much just a review of angle of elevation and depression. So just solving for missing sides and angles using our trig functions in word problem format. All right, so keep in mind an angle of elevation is an angle between, and we can look at our diagram, it's an angle between a horizontal line and the line of sight, meaning the line where you're looking. So if you look at that picture, it's, you know, the line of sight is the line where the person is looking up to the hot air balloon. So it's a horizontal, an angle between a horizontal line. The angle is above the horizontal line, so it's above it. The depression angle is a horizontal line and it's below. Okay, so it's formed, you looking at a horizontal line, and then if the angle goes down, that's a depression. If you're looking at a horizontal line and the angle goes up, it's an elevation. So a couple things to note. The two horizontal lines, notice they're parallel to each other. And we can say that the angles are called, that they're congruent. Okay, you see they're both congruent there. So remember these symbols from back in the day. Congruent. Remember the name for these angles. Alternate interior angles. And alternate interior angles are congruent. So if you drew in a line cutting them, that's called a transversal. Remember that. Okay, so let's just take a look. So angle 1, here's your horizontal. The angle is below it, so that's a depression, angle of depression. I'm just going to put a D for now. Looking at number 2, here's my horizontal, and I'm going up, so that's an elevation. 3, I'm going down, so that's an angle of depression. And 4, I'm going up, so that's an angle of elevation. Okay, why do we need to know that? Well, as we're setting up our word problems, and some of them are going to have to draw pictures, so we just need to know how to visualize and what that's going to look like, that's all. All right, so let's start. So it says a palm tree casts a shadow that's 18 feet long. The angle of elevation is 25.7 degrees. Find the height. So always start by labeling your picture. The shadow's 18. We're trying to find the height of the palm tree. The angle is 25.7. Always compare the angle with a horizontal line. So that's how I know it's this one down here. Now, we've learned other ways that we can solve for missing side lengths in a right triangle. We could use Pythagorean theorem. That won't work in this case, though, because I only have one of the sides. In order for Pythagorean theorem to work, I need to know 2 of the sides. We could use 30, 60, 90, 45, 45, 90 ratios if it was a 30, 60, 90, or 45, 45, 90 triangle. However, looking at it, I see it's 25.7 and 64.390 triangle, so that's not going to work. So in that case, we need to use our trig functions. So we need to figure out which one we have. So we've got opposite and we've got adjacent, so we're doing tangent. So the tan of 25.7 equals the opposite over adjacent, so equals x over 18. So just solve for x. So go ahead and multiply both sides by 18. So I've got 18 tan 25.7. And I'm just going to type that into my handy dandy calculator. 1 second while I get my Wabbit pulled up. Oh, sorry, I can't open it when I'm already on here. So you're going to have to type it on your own. All right, so 18 tan 25.7. 8.66. Now our directions say round to the 10th place. So 8.7 feet. That's the height of our palm tree. All right, in B, it says a sign on the roadway at the bottom of a mountain indicates the road will incline at 10.5 degrees, so not very steep. With the ground, the altitude for car ascending is 3,850. Altitude is height, so that's the side over here. Find the length, so we're finding this. All right, so we got to figure out which trig function. So we're trying to find x. So we've got the opposite and the adjacent. So we're doing tangent again, so the tan of 10.5, tangent of 10.5, equals the opposite, 3,850 over x. I know this time my variable that I'm trying to solve for is in the denominator. So what I can do is multiply both sides by x to clear it out, and then divide by tangent of 10.5. So pretty much these two just end up switching places. So I'm just going to type in x equals 3,850 divided by tangent of 10.5. Now do be aware that it says find the length of the road in miles. Let's just for right now just say feet. You can convert it later if you want to. But 5280 feet in a mile. Thanks, Patrick. So, did I do the right? Well, let me make sure I'm in the right mode. Yep, integrate. All right, so 3,850 divided by the tangent of 10.5, and we get 20,772.7 feet. All right, on to the back. Where's the thing? There it is. All right. We're not going to do all of these together. I'm going to save some for you to practice. So for right now, we're just going to take a look at D, E, and then C on the bottom. The rest you can handle on your own. 20-foot ladder leans against a house. So my ladder's 20 feet. The base of the ladder is 5 feet from the house. We're actually finding the angle this time. That's our theta. So we're still going to do the same thing. So figure out our trig function. We've got the adjacent and the hypotenuse, so cosine. So cosine of theta equals 5 over 20. So remember, to find the cosine, you're hitting second cosine in your calculator, doing the inverse to find the angle measure. So the second cosine of 5 over 20, and when all is said and done, you end up getting, excuse me, 75.5 degrees. Okay, so I just want to do one with you where you had to remember to find the angle measure. So you hit second sine, second cosine, second tangent. All right, let's take a look at E. Okay, from a point on the ground 500 feet from the base of the building, so this is 500, it is observed that the angle of elevation to the top is 24 degrees to the top of the building. And the angle of elevation to the top of the flagpole is 27 degrees. Find the height. So we're just finding this piece right here. Okay, now we're going to do some thinking. You see two arrows over here. We're going to come back to that in a minute. So looking at it, they gave me two angle measures. So this little piece right here is 3 degrees. Can we use that? Can I do a trig function with the 3 degrees and the x? No, two reasons why. I don't know this angle or this distance, and I don't know this one, but also my trig functions only work for a right triangle. So if I'm all of a sudden looking at this triangle right here with 3 degrees, that's not a right triangle, so I can't just use that piece. So let's think about it. They gave me both of these, and they're telling me to look for these heights. So I can find the height of the whole thing, find the height of the building, and subtract the 2 to find just the height of the flagpole. Okay, so in both cases, it's going to be tangent because I'm using opposite over adjacent. So really, I'm just doing the tan of 27. So we'll do the whole thing first. So the tangent of 27 equals, opposite is x, so x over 500. Okay, so really that's 500 of tangent over, or 500 times tangent of 27. And then for my other one, it's going to set up the same way, except I'm going to replace the 27 with 24 degrees. So the tangent of 24 equals x over 500. So that's 500 tan 24. So what I'm going to do, I'm going to subtract them. So I'm going to wait and make sure I get the best answer possible and just type it in all at once. So I don't have to worry about rounding issues. But please just do be careful, because when you hit the tangent, what's called parenthesis opens up. So make sure you close that. If there's nothing going in after it, it's not a big deal. But since I'm typing this in afterwards, if I don't, it's going to take the tangent of all of this, and it's just going to be uncomfortable and weird. So let's go ahead and find that height of the flagpole. Minus 500 tan 24. And you should get about 32.1 feet is the height of my flagpole. Now, if I ask you to find individual pieces, you could tell me the height of the building and all that good stuff. All right, and then let's finish up with C. It says a water tower is located 325 feet from a building. From a window in the building, it's observed that the angle of elevation to the top of the tower is 39 degrees. The angle of depression to the bottom is 25. How tall is the tower? So let's go ahead and let's draw our building. Here's the door. Here's the window. Those things on it. Okay. Now we draw our water tower. There's the top. Here's the tower. Wait, that didn't come out like I wanted. And then there's a tower. That's a cylinder. Here's the legs. H2O. Water tower. All right, so we're saying from here to the top and then here to the bottom. That's the bottom, sorry. We need a horizontal line, folks, because we need that line. So we're just going to draw a little horizontal line in here. So this is my 39-degree angle because it's saying from the window to the top. Here is my 25-degree angle. The distance from is 325 feet. Okay, sorry, the window should have been at the corner, but you get the point. We need to find these. So what we're going to do is we're still finding two, okay, because we're not looking just from down here. If we look from down here to the top, we can find the height in one shot, but we're looking from like, not the middle, but a chunk of it. So we have two different things. So we're doing the same thing we did up here, except we're going to take the two pieces and find the total height, add them together. So I'm also using tangent, okay, so tangent of 39 equals x over 325. So 325 tan 20 or 39, and then I have to do it for the other angle. Tan of 25 equals y or some other letter over the 325. So in my calculator, I'm going to type in, to solve for x and y first, so 325 tangent 39 plus the 325 tan 25. 325 tangent 25. Okay, let's type it in, 2539, close my parentheses, plus 325 tangent 25. About 414.7 feet. The feet, yes, that's a 4. All right, and you can go through and try use the others as practice. Adios.